So we took a look in spreadsheet software about how we can reorder items in a list, and we sorted them. That's great. What if we wanted to transform each item in a list? That's an operation that we call mapping, or transforming each item, essentially changing it, but changing all of the items in the same way. Like multiplying each by 100, for example. That would be one transformation that we could do with numbers. Transform them into some other version of themselves. In spreadsheet software, if we want to do a mapping operation, we'll like reference one of the items at a time and just perform that operation on it, like times 100. And sure, then we could leverage some autofill, I guess, to do that same operation for each item in our list. So each item is being transformed using the same transformation operation. In this case, just multiplying by 100. Hopefully that's not bad, right? We're just changing these items. So then if we want to take like the sum of the transformed items, we can reference those transformed items after we save them in new cells. So in addition to transforming these items, we're also storing them somewhere in their own cells. And that allows us to reference them later, maybe take the sum or something like that. And so we'll do something very similar in Python. If we want to transform each item in a list, we will do that operation like this times 100. Maybe we'll just start by printing those results. But then if we want to use those transformed results later, we're going to have to store them in some kind of new variable. And then we could reference that new variable. All right, so that's the concept that we're dealing with here with mapping or transformation operation. Let's put this into, we'll make some notes about this in our cheat sheet, and then we will pick back up where we left off, where we leave off next class. So no worries, we're not going to get through mapping and filtering today. Maybe we'll just talk about mapping, and then we'll do the rest next class. So it's all good. Anyway, let's talk about mapping lists in Python. So I'm just going to share this with you in our cheat sheet. Sure, we were able to sort the items in a list. Now let's learn how to transform them. So if we have this list of numbers, maybe I'll just borrow one from another example that we did. Let's see, do we have some numbers? Great. Here we have our list of numbers. We can reference it as an entire list. That's all good. Print nums. Cool. Our goal is to transform each number, multiplying it by 100. Also, we want to save the transformed value for later, and then maybe we will take the sum of all transformed numbers. So that's going to be our goal. If we want to loop through each number and print each number, that's a good start. Remember, in spreadsheet software, we had to like reference each one of those numbers, each one of those cells, one at a time. And we need to do that in Python as well. So we could say for n in nums, just start by printing n. When we do sorting, when we do mapping and filtering operations, they're based on looping. So we'll need to do some kind of loop through our existing list that we want to perform the operation on. So here we're printing each number, and that's all good. How could we print a transformed version of each number, like multiplying it by 100? Maybe an easy one, you could shout it out. We're printing each number, but how can we print some kind of transformed version of each number? Yeah. Exactly. Sure, we could print n, or maybe we could print n times 100. That's all good. We're working with numbers here. All right, so now we're actually transforming each number in the same way, multiplying each by 100. Cool. And that may be sufficient in many cases. You've printed out these transformed values. However, the final step in this process is like storing them for later. Right now, we lost access to these numbers. Where are these transformed numbers? When each passing of the loop happens, the understanding of the previous transformed number disappears. So we need to somehow save these for later. Anyone think of an approach that we could use to save items for later? Awesome, exactly right. This is the pattern that we will do. If we want to collect these for later, here, I'll share this version first. That was all good, but we want to collect these for later. So why don't we create an empty list like new nums equals square brackets empty. Right now, there are no items in this list. When we print new nums at the top, it will be empty. But then when we loop through our original list, access each number one at a time, sure, we could print some kind of transform version of it. Why don't we also, or alternatively, collect that value for later? So we'll add it to our new nums list. And what we covered last class was how do we add an item to a list? We'll use the append method and pass in what we want to collect, so that when we reach the bottom, when the loop is done, and when we print our new nums, they will contain all of these transform values. So here we go. That's exactly the approach that we'll use. Questions about what we're doing here? Recall that if we have any list like G equals 1, 2, 3, 4, we can always add an item to it using the append. So we could print G, it'll be 1 through 4. Then we could say G dot append like 500, and then print G again. And we know that this append method is mutating. It'll change our underlying list in place. And in this case, it's adding an item to the end of it. So even if our list starts as empty, we could still add items to it. It's all good. So if G is an empty list, this will still work. It will add 500 to it. Now maybe we can add another item to it, like 700. So this is hopefully demystifying what we're doing when we are appending some item. We're collecting it for later. And the key here, I think, also is creating this new empty list. We need to create it before we do our loop. And then within the scope of the loop, we will collect some item and store it in that list. And it's our choice about what we collect. And this is a mapping operation, and that's it. And we have 3 minutes left. So let's see if we could do one more version of this mapping operation. Oh, I guess just to put a point on this, why are we even collecting these? So we could take their sum, print sum of new nums. Just to close the loop on that example. All right. We just did mapping, transforming each item in the list. When we filter our final operation, we select a subset of the items, only ones that match some logical condition. So if you've ever used a filter in spreadsheet software, creating a filter, I guess, call 1, call 2. What we can do is create a filter and then give it some condition. So, hey, we're starting here with 1, 2, 3, 4, 5, 6 items. What if we only want the items that match some condition? What if we only want the items greater than 5? In spreadsheet software, we can do a filter by condition. And maybe we'll say like the value is greater than 5. So when we do a filter, it selects just a subset of the items, only ones that match a logical condition. The way that we'll do this in Python, and I know this might be way too quick, but we're running out of time, we'll revisit this next class, is using a similar approach to the one we just did. So we will, if we want to filter these numbers and get only the ones greater than something, what we'll do is loop through them for n in nums, and maybe we could just print each. Final question before we break, though. Right now we're printing each number for every number that exists in our list. How can we only conditionally print the number if it's greater than 10? Final question before we break. Yeah, sure, we could print it regardless, but maybe we'll just use an if statement. And so what could we, like, if n is greater than 10, then and only then will we print it. And that's the basis of our filter operation, which we'll return to next class. You can imagine now we'll just only conditionally append this to some other empty list, but we'll return next class. Sorry for going over by a minute. Let's get into a recap of last class where we were talking about filtering lists. At the very end, we almost finished what we needed to do, but let's just circle back and finish this example of what I mean by filtering a list. I'd like for us to start by bringing up our in-class cheat sheet where we were taking some notes at the end of last class related to filtering. And now the second operation that we did with lists last class was called mapping or transformation. And so we practice creating an empty list to store these transform values. And we practice using the append method to add some kind of item to a list. And so here we see that, sure, we could just add items to a list manually like this if we start with an empty list. And then if we add or collect or append the value of 500, it will add it to the list. And then the same thing goes if we do the same thing for 700, and then we'll wind up with a list that has been populated with items. So this append method and invoking this append method on any list is how we'll add items to it. And that's how we collect items for later. And this is especially helpful for us to perform our mapping or transformation operation. So what we did was, if we have a simple list of numbers, or I guess any list, we could create a new empty list to eventually store some items, some transform values. And then when we loop through each item in the original list, sure, we could print out the original item. Sure, we could print out the original item transformed in some way, but we lose access to those values if we wanted to use them later. So if we want to collect these transform values, in other words, n times 100 for later, we just have to collect it into our list that we set up for this purpose. So within the scope of our loop, we append some transform value to our empty list that had been set up to collect these values. And then when we get to the bottom, when we finish our loop, now this new list of that started as empty is populated with our transform values. And now we could treat these transform values or reference them later, I guess. And for example, take the sum of them. So that was our mapping or transformation operation. And in spreadsheet software, we saw how we could just kind of multiply each number by 100, and that performs that transformation operation. So when we perform mapping or transformation, we get the same number of items that we had originally. So if we start with 1, 2, 3, 4, 5, 6 numbers, and if we transform them, we'll still end up with 6 numbers. It's just that they're going to look differently. So that's mapping or transformation. So we practiced that last class. At the end of class, I also introduced you to this other operation called filtering. In spreadsheet software, we could kind of do this manually using some filter capability. When we filter, we get a subset of items, only the items that match some kind of logical condition. So we have to set what that condition should be. And in spreadsheet software, I guess, using this manual process, we could say, all right, let's filter these by condition and specify some kind of condition here, like the number is greater than 10, maybe something like that. And so now we'll only retain the values that match this logical condition. And we see we've arrived at a subset of these numbers. What's the maximum number of items that we'll get back after doing a filtering operation if our original list had 6 items in it? Thoughts? If we start with an original list that has 6 items, if we do a filtering operation of some kind, what's the maximum number of items that we could potentially get? 6, right? If the condition matches all the original items, we'll just get all of them back. What's the minimum number of items that we would get back after performing a filtering operation? 0, right? If there's no items that meet that logical condition, it's possible for us to get no items back. So that's just something to be aware of. Are we expecting multiple items to come back, or 1 or 0? It depends on our use case. But when we're filtering, we're selecting a subset of the items, only ones that match some kind of logical condition. All right, so we tried to start putting this filtering operation into practice in our in-class cheat sheet. Let's take a look at where we left off at the end of class. In our in-class cheat sheet, we started doing this filtering operation. We started with a list of numbers. We looped through them. And we started by just printing off each one. All right, taking this in steps. If we want to do a filter, I asked at the end of class, and someone was like, yeah, why don't we just use an if statement? And that's exactly right. Instead of printing out every value, regardless of what it is, maybe we'll only conditionally print the value, only if some kind of logical condition is met. So here we're saying only if the number is greater than 10 should we print it. And how many numbers should we expect here? I guess like 3. We'll hope to see 187 and 45 meet that logical condition. All right, great. If we said n is greater than 1000, there's no numbers to meet that condition, so we won't see anything. If we say all numbers greater than 0, all the numbers will match that condition. So we're just introducing some kind of logical condition in some if statement. And through your rock, paper, scissors game, you already know how to use if statements. So that's great. Anyway, all right, this is filtering kind of. We lost access to just this set of matching items. If we wanted to take the sum of just the matching items, how could we do that? There's probably a few ways. Right. So we need to kind of collect these transform values for later. And I hear you saying we need to use the append method. That's exactly right. So could you give us some code to get started here? What are we going to append to, I guess? Yep. I'm going to call this one matching nums equals empty list. Yep. It starts off as empty. All right. Now we're looping through our original list and
I'm not sure what exactly what's like append dot.
Yep.
Whatever that output is.
Yep. So when we're using the append method, we can invoke it on any list. And in this case, we'll invoke it on the list that we want to collect items into or append items to. And so in that case, it's the matching nums here, the empty list. So So yeah, we'll say matching nums dot append something, but where should we do this? What line? Right. Only if our condition is met do we want to collect these values, like matching nums dot append. With trailing parentheses, because we're going to pass some kind of value that we want to collect inside. And so that value will be what? What should we collect or append? N, right, N, each specific item here. We're not transforming this, so we could just collect the original item itself. All right. Now, once the loop is over and we hit the bottom, now our matching nums list should be full of all the. Oops, I'm not going to print within the scope of the loop here. So now we see that we have collected just the items that match our logical condition into this list that we call matching numbers. And after our loop finishes, it has all of the items that we collected. And so now I think you're saying, yeah, we could just pass this to like the sum function, for example. And that gets us where we need to go. We collected these values so we could use them later. In this case, so we could sum them up. I'm going to share this in Slack now. This is the pattern for filtering. All right. Like mapping, we need an empty list. Like mapping, we need to loop through the existing list. Like mapping, we need to collect some kind of item for later.